we go back to the unit circle, what is the value of sine of 0 radians? What is the y value at 0 radians? It's 0. What is the y value at pi over 2? It is 1. The y value of pi is back to 0. The y value at 3 pi over 2 is negative 1. And then the y value at 2 pi is back to 0. All right, so that's how we first learned how to, whoops, I put that in the wrong spot, graph sine.
Didn't we learn how to deal with like spaghetti noodles?
We also did some spaghetti noodles. Y'all love that.
But we couldn't eat them.
You were asked not to eat them because they were like 600 years old and had lots of hands touching them.
Wait, we weren't supposed to eat the noodle?
Are you serious?
All right. So, on this same graph, we are going to graph the reciprocal function of sine. What is sine's reciprocal? Cosecant.
No, we're not learning something.
Okay.
I understand we're going to learn this.
So, let's talk about cosecant. Now, the tangent, we discovered that when we did the reciprocal of all these zeros, what happened?
Asymptotes.
We now have asymptotes.
Asymptotes. Is that what happened too?
Yes, it is, because the reciprocal of 0 is undefined. So all these places where the original function was 0, its reciprocal function will be undefined.
There's only one space in between?
Yes.
Correct.
That is
Bro.
There's
All right. So now let's kind of yeah, I don't know what that is. Okay, so now let's think about the easy ones. Let's do the easy ones. Okay, so what is the reciprocal of positive 1?
1.
1, that was easy. What is the reciprocal of negative 1? 1.
Negative 1.
Okay, 1, negative 1. All right, those points were easy.
Wait.
Okay, so the reciprocal of 1, if I flip 1, I still have 1. If I flip negative 1, I still have negative 1. All right, now I'm going to pick one like pi over 6. Okay, so what is the y value at pi over 6?
What is that? 30.
What is it?
One half.
1/2. So if I flip that, what is it?
2.
2, so it's up here. Okay, let's do like pi over 3.
1 over the square root of 2. Square root of 2 over 1.
1.5.
Square root of 2.
So it'd be 2 over the square root of 3.
Oh wait, no.
It's 3 root
I'm thinking of
2
the wrong.
over the square root of 3.
2 over 3.
No, it's 3. It's square root of 3 over 2.
Okay, so that's what it
You
is
go.
for sine.
You go like
So if
flip
we
it.
Flip
do
it.
the reciprocal,
2 over 3.
it's 2 over the square root of 3.
Oh,
All right,
I
try that.
Is that, wait,
Use
that's
your
like
calculator.
1 point.
It's like a little bit between
not
1
wait,
and
2
2.
over the square
root of 3
It's
right?
point something.
2 over the square root of 3. Yeah.
It's 1.
No, it's
1.5.
It's a little bit close to
1.5-ish.
like 1.2.
Alright.
Yeah.
So, okay, let's come over here to like 2 pi over 3.
The parabolas.
It's the same thing, isn't it?
Yeah.
What about 5 pi over 6?
That'd be
We have
2.
parabolas.
Maybe that's 2. Okay, so what's happening is it looks like this.
parabola?
Okay, it should be prettier. It flips it
If
up.
they're positive, they point
Now,
up. If they're negative,
just like tangent looked similar to a cubic, this looks similar to a parabola. It's not a parabola. All right, what do you think is going to happen here?
Same thing
It's
down.
going to be the same thing, but it's going down. Actually, this one kind of looks a little better. Yeah.
Fatty. Fat.
All right, so this one's going to go down, and this one's going to go.
on the test or quiz or whatever, are we gonna have to put each point or just the
Like, can we put the first
Can we just put the point or
paragraph for cosecant?
Okay, so how would I graph this without first drawing the first one? We'll do that in just a second. But now let's look at the characteristics of this. How long does it take us to find all of our values? 2 pi. So that would mean our period is 2 pi. All right, we didn't have any horizontal shift, we didn't have any vertical shift, and it's not a wave, so we don't have an amplitude.
Oh my god.
But we are gonna have
Okay? All right, so let's do another one. Alright, how would I graph it if I didn't have that first little sign to start with? Let's say I have y equals 2 cosecant of 2x plus 3.
Why is you said no amplitude?
What?
Okay, can we have a vertical stretch even when we don't have an amplitude? Yes. Alright, so let's graph it. Alright, so this one we are having a vertical stretch. We have a change in our period, don't we? If normal period was 2 pi, this period, what will the fourth tick mark be? Pi. Alright. And most of you guys did a great job on your quiz labeling all of these. Some of you did that.
Is that okay?
I know.
But what if the middle one's pi over 6?
For the one,
You have to. And the directions even said, make sure you label your x and your y axis.
I put
I labeled my X, my Y.
Alright, so we need to identify all these critical values. Alright, so I'm going to count by ones this time.
It's not worth it anymore.
Oh, wait, we have to label all of them? I kind of just skipped the 3 and I kind of. Yeah, I did that too. Like it was like a
Yeah, you're getting points.
If you labeled everything that was necessary on the y-axis, I gave you credit.
Okay.
If you skipped the ones on the x-axis, you lost some points.
Okay.
I definitely lost on the last.
Alright, so we, if we were graphing this like it were sine, we would throw in our midline. If those of you that don't graph in a midline, that's fine. Don't do it. Let me see if I can get it. I moved only one side of it. That's what I was trying not to do. It's hard to grab what you.
Oh, that's cool. That's a hat.
No.
Maybe delete the line and remake it.
I can't. Oh, there we go. I grabbed it. I grabbed it both.
Well, you know, Miss Wilby, you tried.
And that's not good enough. We just talked about that.
Or you can.
Trying is not good enough.
See, if you just continue yourself with trying, then you can
Or you
write
could just
your own
maybe
life.
you can just write.
There we go. That's what you do. That's how you do it, folks. Alright. Now, I didn't give us a horizontal shift. That's alright. It's alright. We can do a horizontal shift if there was one, right?
Don't need to.
Okay. But I didn't give you one. So at this point, I would plot just the vertices. I mean, just the middle high, middle low.
As if it were sine.
As if it were sine.
But don't draw the sign graph.
But don't draw the sine graph. That is correct.
Yeah.
Correct.
I would just draw in the middle high, middle low values. Okay, and then I would go directly into drawing in what does matter. So my asymptotes this time are going to be where it crosses the midline. Okay, so there's an asymptote. There's an asymptote. Here's an asymptote. Here's an asymptote.
Well, we have to put the little things on the graph.
Here's an asymptote. Alright, so this was my midline, which I should have labeled.
New x-axis.
Sure, you
So
can
is it
label it
safe to
that.
say it's impossible for a cosecant graph to pass this midline to intersect?
It does not intersect the midline.
Yell hi to them.
Okay, so this one would go up, and this one would go down.
You just follow the.
You follow along the asymptotes, that is correct.
And on the test, we won't have to label little points.
On the test, you do not have to label the little points in between. We just tried those on the first one so you could understand I wasn't just making stuff up.
So once we figure out the asymptotes,
Uh-huh.
the rest we just draw in
Yep, the rest of them you just draw in.
This is a breeze.
I think so too.
Three.
Yes.
So I'm not.
If it was like an inverse,
By inverse, do you mean if it was negated?
Like that.
Yes.
If it was negative right here,
When the things flipped around.
then this would come down here,
Okay.
and this would go up there. So if it was negated, this would be down here, and this one would be up here. Because a negation of the function causes a reflection over the x-axis. And when we're doing transformations, that reflection always occurs first. Okay.
Would secant look really similar to that?
What do you think?
Well, I feel like it would. 'cause-
It does.
Yeah.
But
So
it's
with secant, well, is your reciprocal function for secant? Which function is the
Cosine.
reciprocal? Cosine.
Cosine.
So you would do the exact same thing, except you would be using cosine instead of sine.
So how?
Everything else would work the same. Okay? Yep, it's homework time. That's all there was to it.
That was easy.